We're going to build a storage server and explain about going really fast with a storage server. This is an LR-Link 400 gigabit Ethernet adapter. Well, it's 2x 200 gigabit based on a Broadcom chipset. It's designed for server and some server airflows. Look, the whole card is heatsink. 16 lanes of PCIe Gen 5, but that's what's needed to keep up with just a few of our Kioxia CM7s. I've got a bunch of CM7 drives here, and I want to see what we can do to build as fast and as low latency a storage server as we possibly can. It's a little bit DIY because I've had some inquiries to do that for VFX and video production and all the other stuff. And as I was looking into that, I sort of discovered some things. So let's talk about the plan and talk about why that has historically been weird. And I think that this is a sign of a sea change of things to come. And let's talk plan and then get into the ridiculous amount of storage. And yes, I am hoarding storage in our storage shortage era because terribleness. Now this is awesome. Kioxia has always supported my mad science, and I'm always grateful to that because these are a lot of fun to play with. These CM7s, 15 gigabytes per second each, and they are very low latency. If we're DIYing a server or we're trying to, keep things limping along, this might seem like an unusual choice, but when we're talking about storage and storage going fast, there's really just, off the top of my head, I can tell you there's Weka and Pure Storage, and there's probably a lot more. But I was looking at what the state of the art is in the Linux kernel, and then what the state of the art is in communities, and I was sort of noticing a discrepancy. So for this, we're going to try to put together a kind of a DIY system, and I'm going to start with just 4 of these. And I want to see what it takes to saturate our dual 200 gig link here. 400 gigabit. I should be able to clear 40 gigabytes per second, assuming the rest of the system can keep up. Now, in order to do that, I'm going to need PCIe Gen 5, because 16 Gen 5 lanes tops out at 64 gigabytes per second, you understand. And we're also going to need low latency, and we're also going to need good software support. And all of those things coming together, you'd be surprised how many organizations out there, even open source organizations or folks that depend on open source, are not really helping you connect the dots to get to the other side of something that is fast and exciting. There's also some not fun aspects of this from the software side. It's like, let's do this all in user land. RDMA, that's going to be a little challenging, especially if you're depending on kernel modules to do some of the the information exchange. And I'll explain what I mean by that in a minute. It also matters a little bit if you're going to interact with Windows or Linux. A lot of nonlinear editing packages like DaVinci are available on Linux, and you may have a better experience when we're talking about storage performance and low latency and that kind of thing on the Linux side of things. So I'm going to start with an older machine, Sapphire Rapids. It's the first machine to support PCIe Gen 5 from Intel, but I happen to have one, and it's very fast, and it supports a lot of memory, 8 memory channels to be sure. And it should work with this 200 gig Ethernet adapter. Sapphire Rapids is too old to support 400 gigabit? Kinda. I mean, it is one of the first, I think the first PCIe Gen 5 Intel platform, but no post. The network card needs bar space and everything else. It's got to update the BIOS. And in our test system, I've got something like this. 16 PCIe Gen 5 lanes to 4 E3 bays. You could use E1 in this as well. The idea is that I can install 4 of our E3 drives, our E3 CM7s, and then turn on bifurcation, and then this will work. The problem is that not all of these work properly at PCIe Gen 5, and some of them will work properly at PCIe Gen 5 depending on the motherboard and depending on the slot that you put it in. So you might get errors. So if you don't get errors, then this will do 60 gigabytes per second, which is amazing. Yay, CM7s. Man, Kioxia makes good stuff. Now this is our Falcon Northwest Talon system. This is the older one. This is the Intel-based one, Sapphire Rapids. This is what I'm using as a stand-in to test. And see, I've got 4 of those Kioxia CM7 drives in here on a PCIe carrier card. So they're E3 drives, just like it's going to go in a server, but this is a more convenient format for me to experiment with. We'll be able to run tests, do crazy stuff with Linux, reset the BIOS. This is a lot faster resetting and dealing with the server and all that kind of stuff. And so this is a more convenient platform for me to experiment with RDMA and everything else. Plus, each one of those CM7 drives is 15 gigabytes per second. So if I can manage like 25, 30, 35 gigabytes per second on this platform, I know that I'm going to be able to do it with a higher end, newer platform, something based on the 6900 series Xeon socket. And I may be able to come down from that a little bit because this is an 8 memory channel platform. We'll see. This is the other system that we're using for our creative workloads. This is a 96 core Threadripper Talon system, 768 gigabytes of memory, 16 terabytes of local flash storage, and also a 100 gigabit network connection to our 400 gigabit backbone. This is running the creative workloads, Render, Deadline, Houdini, all of the creative workloads. And this is the fastest workstation machine that I have in the building. I've got another Threadripper system, a 64 core 9980X, also connected to the same system, also generating workloads. But this is an unstoppable machine for pretty much any creative workload. It's just, can we build a networking storage backend that can match what this thing can keep up with? The other unlock here is networking. The CRS 812, I think, from MikroTik. This is an interesting little switch. It doesn't have a ton of ports. It has 2 400 gig ports, 2 200 gig ports, and 8 25 gig ports, and then some management ports. It's not a lot of ports. But if you had, say, 4 dual 25 gig workstations plus some higher speed workstations, this would make a pretty good workgroup switch. That 400 gig port, it is possible, because it's double data rate 400 gigabit, to get a breakout cable that goes from 400 gigabit QSFP56DD to 200 gigabit QSFP56. So you'd have 2 200 gig QSFP56 connections into a single QSFP56DD connection. There's kind of a lot of insanity in this frame. Don't worry about it. So what we've got here is an FS direct attach cable, 400 gig DAC. It's my breakout cable. You see, some of these Broadcom adapters gives you 2 200 gig ports, or you can use one of the ports in 400 gig mode with the other port disabled. Now the NIC that I have doesn't do the single 400 gig mode. So I had to buy this ridiculous $186 cable. All right, so our MikroTik switch is 2 400 gig ports, 2 200 gig ports, and 8 50 gig ports. SFP 56, and then QSFP 56, and then QSFP 56 double D, the double data rate. And if you look at this thing, it is absolutely redonkulous. The circuit board is extended a little farther, and there's a zillion little gold contacts on there. So if this were the 400 gig card, I could just use a 400 double D cable. And like, this is a short DAC cable, so this is not even really optics. It doesn't generate as much heat, doesn't use as much power. This is sort of fantastic for my testing workgroup switch. And, you know, again, remember, I'm just using this Falcon Northwest system to test and get my software going before I put it in a big loud server that has 24 drives. I just want 4 drives, you know, just some basic geometry here to do the experimentation. But I want to take advantage of both ports on my NIC. So I can get a special cable that'll go from the 400 gig double data rate to 2 200 gig ports. But my recommendation would be to look for a NIC that has the 1 400G mode where it can do 1 400 gig port or 2 200 gig ports, because it disables the second 200 gig port if you don't do that. Now this NIC, I thought maybe, because sometimes you saw this on slower NICs, that you could use, like you could throw a software flag and like combine both of the 200 gig interfaces into one interface, like on the NIC. It doesn't work that way with these NICs anymore. And that kind of makes sense. That was a Mellanox thing, kind of sort of a long time ago. And it was really more on the InfiniBand side than the Ethernet side. And they got away from that pretty quick. But this gives us 2 interfaces. Now, this MikroTik switch does have dual 400 gig ports. And so I could run 2 of these adapters, both of 400 gig, and then I would have an 80 gigabyte per second connection to our storage server, and that might actually be within reach of what KSMB can do with SMB multi-channel and all of the plumbing in the kernel. I think to do that, though, I would really much rather have a dual socket, dual processor server where each of our 400 gig interfaces goes to its own physical socket. That's really thinking outside the box and spreading the load, but that's going to be a different video for a different day. I think we can be really satisfied with 40 gigabytes per second as opposed to 80 gigabytes a second in this hypothetical dream world. And once we move beyond our, Falcon Northwest Talon workstation test machine. The eagle-eyed among you probably also noticed that Threadripper machine back there. Yeah, that's another Deadline render station. And you might have noticed that it has the forbidden Chinese GPU in it from Huawei. Don't worry about it. It's about a $200 cable at the time that I'm doing this. But that would let you connect this dual port NIC at 400 gigabit, 2x200 gig, to your MikroTik switch at 400 gig. I believe the other 400 gig port free to connect to another MikroTik switch or another high-speed device, and also your 200 gig ports, and also your 25 gig ports. You also break out the two 200 gig ports into 4 25 gig ports each, so you could support 12 workstations on this thing without a lot of headache. 12, I mean, upwards of 16, or 8 50 gig 2x 25 gig workstations off of this MikroTik switch, which is really good considering the price. But it remains to be seen if it's going to work. We got to do the setup and the test and everything else. But I think I'm hopeful. I think this is going to be good. The other point of this video is that the information that we're building here is going to go in the Level 1 Techs forum, because there's going to have to be a guide and some other information about setting this up. Now to start, I'm going to use Rocky Linux. Rocky Linux is a clone of Red Hat. Why are we using a clone of Red Hat? In order to do all of this, in order to do the low latency, we need something called RDMA. You see, it's not like, fundamentally, if you're thinking, it's like, hey, things feel differently, storage has changed, you would be right. Because in the past, like for 1 and 10 gigabit Ethernet, there was a lot of innovation happening and a lot of excitement, and people like me just really excited to play with technology and do stuff with it. 100 gigabit is insanely pedestrian. I've got those color chip adapters that are available everywhere. Those are like $6, $7 each. If not for the sheer demand of enthusiasts like us driving up the prices, those Mellanox ConnectX 5 NICs should be like $25 on eBay. They're not. They're like $100. And that's just because no one else is really doing anything with that. But we've also got Intel coming in with the E810, and they're doing 25 and 100 gig adapters for reasonable prices, $100-ish. Minis Forum has this amazing little 25 gig plus dual NVMe, and I've ordered like 4 of those in addition to the one that came in the Minis Forum Intel PC because it's pretty good. It's dual 25 gig, and it's got a fan, which works great in a workstation. If you plop this in a workstation, it's not going to work. Why is it not going to work? Because it's going to overheat. So anyway, let me try to offer a more complete explanation for the software stack and all the other pieces. The RDMA part is offloading processing to the NIC. So the NIC is able to read directly from system memory, do stuff, and the system memory is able to write, well, the NIC is able to be notified there's something in system memory. So the NIC can go pick things up from memory and drop them off in memory. That's great because it bypasses the CPU having to do computations about what's going on. That's true of the far end as well, and that's also true of the switch. So like the switch, the NIC, and the far NIC all sort of talk to each other, make an agreement, and then big bulk data transfers happen. The reason this is important is because if you look at the latency, how long does it take the system to look at an individual packet on the network? It is kind of a long latency, and the latency will kill you for creative workloads, but the latency will also kill throughput. If the machine has to check every individual network packet, that is an absurd amount of computational overhead. So instead, the transaction, the handshake, is checked. And once that is approved, then a large amount of information can be transferred without every single individual packet being checked because they're just shoving the data in and out. I mean, it's not really technically accurate to say that it's not checked. It's just that it is handled at the hardware level. The NIC is trusted to handle that. And that is where a lot of people run into trouble. It's like, oh, I've added a 100 gigabit network card to the thing. I've set up Samba. Why is it slow? It's taking 100% CPU. The CPU is trying to do all the work. You don't have all of the plumbing for RDMA at the NIC, at the switch, through the whole channel. And not really anybody is telling you about these kinds of caveats and landmines. Like, just because it works doesn't mean it's working optimally. And it's not just RDMA. There's lots of little software gotchas. Red Hat has to support a lot of enterprises, and so Red Hat has done things. They've modified their distribution in ways that are a little more conducive to these kinds of things that we're going to need to do to squeeze as much performance out of things. And this is really weird because, I mean, I say that, and as a practical matter, that's true, but like where rubber meets the road, kind of a thing that's not necessarily true. I'm going to pick on TrueNAS for a little bit. And I don't mean that intentionally. Like, they're doing fine stuff. They've just made some odd choices lately. And by way of example, we'll talk about TrueNAS. So IX Systems makes some really killer enterprise stuff. And their enterprise stuff has RDMA and RDMA acceleration and NFS. This is not really supported. They don't extend it to their, community stuff. And the community, Goodwill, all this other kind of stuff. There's also a kerfuffle with Smart, where they took Smart scheduling out from the user, and then they added it back. But when they added it back, they weren't paying attention. And so things like, whereas previously you could monitor the smart wear level or the user scheduled, like notify me if the SSD is reporting less endurance than it had previously. That is broken at the time that I'm shooting this video, even though IX Systems came out and said, oh, we added that back. Embarrassing, terrible. Yeah, I know. But the enterprise products are actually good, and that's where they make their money. The problem is that the culture and everything else is shifting. What started as we're going to build something in open source where there only exists commercial alternatives and make something with open source and have it do really well, or like try to put something to the community together and then we have some options for upselling. I think that people have become, or like buyers are becoming much more sophisticated, and people watching this video understand that, hey, maybe I don't want to, it's like I understand that these commercial solutions are really amazing, and they've done a lot of work and they've put stuff into it, and they're entitled to charge for it. They're entitled to, present and use their product however they want. But I don't want to be surprised by ABC, XYZ, by, there's a lack of RDMA support here or anything like that. People don't know that they really need it. But the dam is about to break on this kind of thing, I think. And we saw it a little bit with some of the stuff that Red Hat themselves was doing, and we saw this a little bit with the Smart thing from IX Systems, and we see this with other open source projects. So coming down from my soapbox a little bit, we're going to be using Rocky Linux. And Rocky is what we have now that is a Red Hat path, but not from Red Hat, because Red Hat killed the open source CentOS. Like, they acquired them and then they just quietly sort of turned that off. And that was not great, and it sort of frustrated a lot of people. But Rocky still has a lot of the plumbing here. Rocky is also not super weird about supporting ZFS, for example. Although if you're going to do that, in this video I'm showing Rocky 10 mainly, and the tutorial on the forum is for Rocky 10. You want to use Rocky 9 for ZFS. Really important point. If you want ZFS, go for Rocky 9, at least right now, when we're talking like March of 2026. That may change soon, because Rocky 10's been out for a little while, but Rocky 9. The how-to also walks you through building KSMBD, which worked for me on Rocky Linux 10, but I did have to build my own DKMS conf, which I am sharing on the Level 1 Text forum. And you can use that to get your kernel mode connections here. And that's the other part of this, like RDMA and the RDMA plumbing. A lot of testing, like Broadcom, doing a lot of testing on SUSE and Red Hat and sort of these commercial OSs, and I wanted to short circuit to the most operational path so that this is already a long enough video already, and it's really more of a political video than a technical video. But I'm telling you this because there is a lot of technical debt here from ignored situations that are coming due. And I would love to see IX Systems say, oh, you know what? 100 gigabit is pedestrian, and RDMA is a must support in 2026 because the latency considerations mean that the 10 gigabit experience is not as good as it could be because we have the CPU round trip latency. The 25 gigabit experience is not as good as it could be because we have the latency of having the CPU have to deal with things instead of dealing with full hardware acceleration. Segmenting products in this way doesn't make sense. And when you, the user, discover that you've been bamboozled in this way, generally you don't really take it well. It's also true that like RDMA support is pretty well supported, even going back a few generations, like picking up a Mellanox ConnectX 4, ConnectX 5, there is a path. There's also some terminology here around InfiniBand. InfiniBand is one way how this got started from Mellanox all the way back in the day. NVIDIA, of course, acquired Mellanox, and a lot of the InfiniBand verbiage and InfiniBand utilities still apply even when we're talking about RDMA. And then this other thing called RDMA over Converged Ethernet, where we're doing RDMA-like things, but over a physical Ethernet channel. And that is completely okay. So like you don't have to have InfiniBand to do these things, especially when we're talking about higher end stuff. And so the plumbing for this is kind of there. Some of it is not mainline kernel. Some of this has been patched into the Linux kernel. Red Hat has done some of that in their supported stuff. Red Hat does not support KSMBD and doesn't provide support for it out of the box, I should say, and doesn't provide support for ZFS, obviously because of the licensing considerations. But there is a path to build that. And what I don't see are enthusiasts connecting all of the dots on all of these things yet. But I think, like I say, the dam is about to break, and just pointing it out is probably going to create an avalanche of folks that are working on this. And I'm starting working on this by creating a post in the Level 1 Text forum talking about Rocky Linux and how we got there. So let's get this put together. Let's get our disk going and see if I can get just 4 of our CM7s to saturate 400 gig Ethernet and what I actually have to do to get there. Or I could fail catastrophically. Let's dive in. So this is Deadline. Deadline is part of like the VFX pipeline, rendering, that sort of stuff. What you have to imagine is that we've got a bunch of these machines that are connected to a storage network. And when a VFX artist is using this, the network traffic pattern looks way different than when they hit render, or it looks way different than when Deadline kicks off a job, because Deadline is kind of an orchestration thing that VFX folks use. So from a networking perspective, when Deadline kicks something off, it's going to use a significant amount of the network connection that this machine has. And if this machine is connected to the network at basically the same speed as the server, or the storage subsystem in the server is slower than the network, then it's possible for one of these machines to monopolize the connection. I mean, you can do quality of service and other configuration, and you can get into exotic stuff like that, but if you haven't bothered to really think about the storage geometry and what's going on with the storage system, you probably haven't bothered to set up quality of service or anything like that either. So this excursion, this project, the documentation on the Level 1 forum, the walkthrough, my aim is to try to create a situation where we could have, 6 or 8 editing workstations reasonably connected to a relatively high-end DIY storage server, but that can also keep up with this, or at least when somebody clicks render on one machine, it's not going to make the experience get a lot worse on another machine. I mean, it might, get a little bit worse, but I don't want it to be a situation where somebody can't work interactively on one machine when Deadline is running some jobs on other machines that are otherwise idle from having somebody sitting at them doing work. That's the plan, anyway. Rocky Linux 10 KSMBD. I love the KSMBD GitHub page. I'm not even 100% sure that I'm looking in the right place because there is this other repository. But look, multi-channel, SMB Direct RDMA. That's really the one that we want. And, they have some graphs. There's some throughput here. I can probably give you guys some better graphs that, from 49 to 53 megabytes per second. Not all that impressive. Just being honest here. I'll probably give you some better graphs. But supported kernel versions, 5.4 or later. Oh, that's, yeah. When I was compiling, I got some weird redeclaration errors. I ended up doing my own dkms.conf. Check the forum for the guide on that. But it loaded. Yeah. Got our Broadcom ROCE driver. We've got our, it's all here. And don't worry, we'll fall back to RDMA over NFS, or NFS via RDMA instead of Samba. But it's not even Samba, SMB. If this works. This is another common thing that I see in Level 1 forums people trip over that is a performance killer. You can have error reporting turned off, like AER, PCIe AER, and that's bad because you don't see errors like this. Hardware error from AEPI generic hardware reaction 0. This is coming from the adapter PCIe card that I'm using to plug in our E3 drives. Which slot you use on the motherboard matters a lot. Generally, closer to the CPU is better and farther from the CPU is worse. However, on some ASUS motherboards, especially the newer Threadripper motherboards, ASUS has redrivers or retimers that are for the lower slots on the motherboard, and that will actually improve PCIe Gen 5 signal integrity on the lower slots if it doesn't work in the upper slots, which are just wired straight into the CPU. So, be on the lookout for PCIe errors reported by the system. Pay attention to that. And this is another common pitfall. It's like, oh, I'm just in a hurry. I want to plug this together. It's like, no, there are lots of little pitfalls like this one, and this one is a really common one. Okay, so where did we land with the storage server? Well, this is going to have to be part 1, because I ran into more problems than I thought. Mellanox Connect X5, because it's Mellanox and it's been half abandoned by NVIDIA, companies like HP and Dell have their version of the driver. And when you download it and you install it, it's the Mellanox version. So you can go to HP Enterprise, download it, and then in Device Manager, when you query the device driver, it'll show Mellanox versus Microsoft. But I'm not actually sure if the Microsoft version or the Mellanox version is better. You see, when you enable, or when you try to enable RDMA in the driver properties, get RDMA enabled, it's supposed to work on Windows 11 Pro at this point. Like RDMA in Windows 11 Pro should be a thing. For a while there, Microsoft only enabled this in Windows 10 for workstations. You know, yay, product segmentation. But I'm pretty sure I had it working in Windows Pro, but I'm having trouble getting it working in Windows Pro. Now, RDMA for Linux clients, if you're going to run DaVinci Resolve or some of the Houdini stuff, that's fine. Running Deadline with lots and lots of CPU overhead, also fine on our Falcon Northwest Windows machine. So if you're using KSMVD and RDMA, I want to hear from you, and I want to hear what your configurations are and what sort of performance you're looking at, because that's a little weird. I've also got the Intel E810 adapters, and those work. But I'm surprised the Connect X5s, because like, wouldn't it be nice if the Connect X5s work on eBay? So I'm still working on this. Check out the forum thread. We'll connect the dots in the forum thread for this for the storage server. But I want to, like, this works well enough. I want to go big. And going big, it's going to move to that 24-bay E3 server, thanks Kioxia. And we're going to move to faster networking enabled by the MikroTik. MikroTik also just enabled quality of service. I thought this was going to have to be another video later. Spoiler alert. It is, but not for the reasons I thought. MikroTik quality of service on that switch means that some of the jittery, bad user experience we can manage at the switch level and say, hey, these clients, make sure that a particular client doesn't monopolize the connection to the server, as long as the bottleneck on the server is always the network, not the storage and not the storage latency. You see, that's the needle that we've got to thread here when doing this kind of workload. So that's enough for this one. I'm Wendell, this level 1. This is the stuff that we go through to make storage servers go absurdly fast for DIY. For not DIY, there is, of course, always Weka or Pure Storage. But that's a story for another day. I'm Wendell, this level 1. I'm signing out. You can find me in the level 1 forums, working diligently on part 2.